So hello, yes, I'm Mark Noonan. I'm a product manager here at Cypress. I have started here as a developer and moved into product as we started to create these app quality products in Cypress Cloud. Um, so I spent a lot of the last couple of years talking with customers about how they manage things like accessibility and test coverage, and how those things are related to like their overall strategy and approach to different things related to quality. So in this talk, I kind of want to answer one of the questions that comes up the most for me, which is a little bit like, how is everybody else doing it? Because I will have hundreds of conversations in a year about different aspects of quality with different teams. And often people are curious just around how other people are thinking about quality and like using their Cypress pipeline. So I'm trying to use this presentation to bring a bunch of that together, and show towards the end as well a little bit about how the UI coverage and Cypress accessibility products play into that, so you can maybe try those and see if they're a good fit for you. But really want to focus on like the idea of quality first. And to prepare for this, I took a look for just some numbers around the impact of quality. I found this one interesting. This describes 59.5 billion annually as the cost of low quality software and bugs. And that seemed like a large number to me. And then I noticed when this study came out, which is 20 years ago. So that was the number back then. And back then, I hadn't even contributed any bugs as a developer. Things were a lot different back then. YouTube was just launching and stuff like that. So I was curious about some updated numbers. This one's much bigger. This is like I'm sure a different kind of study, but that's a 2.41 trillion instead of billion. This is a much bigger number in terms of software quality and the risks around poor quality. A lot of this comes from security and lost income related to bugs and things like that. So definitely bugs are important, and they are a drag, and quality itself can be like a booster or a drag in the usability of our products and their adoption and success. So of course, if it's that important and it's costing a lot of money, it's nice to find out whose fault it is, right? Who's the one that's making the quality bad? If we could just find that person and tell them to do better, then the quality would improve. If we just tell them don't make quality mistakes. But in reality, what we see sometimes is it's kind of a distributed responsibility. So in some cases, it might look a little bit like this. The person who's responsible for quality, maybe it's the developer who made the bug, or maybe they're going to point at the QA person who didn't detect the bug. That's kind of a narrow view, but it can feel a little bit like that sometimes, right? That we're trying to help each other succeed at the same time. It's human beings doing the work, and we're imperfect, and we're making decisions all the time about how we're implementing stuff. And so there's a lot of opportunity for things just to go wrong in the software development process. But then you could also bring product into it, and they could both say, well, look, we had a vague specification for what this functionality is supposed to be. So the understanding was not shared, wasn't communicated clearly enough between somebody who is implementing this and somebody who is developing the tests and things like that. And even within the same team, just the understanding of like how well is the intended behavior specified and understood and communicated, all of that can influence quality. But you could also get a little bigger. So maybe potentially a lot of people are actually involved in quality problems, and finding a single source of blame is not productive. And finding a single factor that we can improve that's going to have a knock-on effect on the rest of quality is also not really possible. In this talk, we're going to talk about that there's not necessarily a holy grail of the actual answer to make this one thing better, and quality flows from that. But there is maybe a process and a way of thinking you can adopt across all of these different areas. And by adopting that type of process and collaboration, we actually can see good quality emerge from the accumulation of efforts across everybody in this type of loop. There's a few different approaches in here. So I'll start by saying quality is more than the absence of bugs. We'll definitely spend a lot of time talking about testing, but testing fits into something that you're doing to raise the quality of your application or try to guarantee it, and skates around it and things like that. So if quality is just not having bugs, then design isn't necessarily a part of quality. Building the right product wouldn't be a part of quality. Meeting the needs of the users wouldn't be a part of quality. So it's not just about having things that function as intended. It's also about the factors that go into the experience itself. So to me, the biggest view of this is to say that quality is about the entire relationship with the company. Everything that you do around how we define the relationship with customer service, how you define your documentation and how you market to people, all of that influences the perceived quality, and these things go together. So my example in here is if you look at an aspect like customer support time, right? Are we responding to customers in a reasonable manner? Are we helping them solve their problems from that particular angle of the business? We can reduce that time maybe by adding support people, just directly saying, hey, we can have more people to take calls or something like that. But we can also reduce the amount of people who need customer support by improving product quality itself, by improving documentation, by improving the ease of use and discovery in the design and implementation of our products, so that the needs of customers are more easily met and they don't require engaging support for as many things. That then means the metric that we might look at around support will improve, but not by focusing directly on the throughput of that point of your system, but instead on the factors that generate the throughput. Within quality, there's a lot of different signals we can pick up on, and testing is one huge way to get like tangible signals about whether something is red or green or working correctly. And it can also help with some of the intangible things about quality. It can help you discover things that are related to quality, but not necessarily directly measurable in your tests. So I'll give some examples of what I mean by tangible and intangible signals, and our efforts to generally pick up these signals and use them to make our products better. Some of the stuff we can directly measure. A good example is test pass rates. Cool, passing tests are good, failing tests are bad. That's a pretty clear thing we can look at, and how often are our tests passing, especially on deployed branches and things that are actually release candidates, as opposed to tests helpfully passing as you experiment on your own branch as you build something, in which case you can use test failures to help you understand the impact of a change. It's not wrong for those tests to fail. It's not a problem in your product. It's just the development process using the tests correctly. I also look at test flake rates. That's something that is a part of Cypress Cloud and something that Cypress users are interested in. I've developed this opinion about test flake, which we're not going to get into too much here, but quite often when I've looked into flake in detail, it's not some quirk of the test setup largely, unless it's maybe a super changeable UI and we're depending on something unstable. But that's not really flake. Right? Those tests will fail always, usually. And so that's just tests failing and being brittle, which we can address on that basis. But where a test is flaky, it's passing and then it's failing with the same test code and the same application code. And all it's changing is we are rerunning the test. And this is a pain point for testing. We often try to solve it from testing. But I'm seeing over and over that the underlying cause of flake can be these hidden race conditions in the application code that would affect a user on different devices and conditions and connection speeds. And sometimes that's why it only appears in CI on a smaller resource machine or with some different conditions from how we work locally. And so understanding flake and addressing flake is directly tied, in my mind, to at least proving that it's not hidden race conditions in the application. So absolutely solve it outside the app if you can, but it's something that's really interesting to look at. We can also tangibly measure the timing of performance, although whether the performance is acceptable and feels right is more of an intangible judgment call. So we have the ability to take the tangible things and infer and to draw a line ourselves for the intangible things. Likewise, we can look at core business metrics. Are people signing up? Are people paying for the product? We can look at hard numbers around the numbers of bugs that are reported and things like that, and even things like communication with customers. So obviously this is not an exhaustive list, but there's a lot of things we can measure, and I know that people gravitate to what is measurable as the sign of quality, sometimes to the exclusion of the intangible things. This is a fairly common expectation. So there are things that are harder to measure directly, but also very important to the experience of quality by the user and by the people who are looking at your product and trying to get their workday done by using your tools. At least that's a scenario I think about a lot, not as much as public-facing stores and things like that. So we look at product quality. Is it actually doing the right thing? Have we made the right implementation of the decisions that support the use case, like as best we can within the constraints that we have? Or the design quality. Are we building something that is easy to understand and use, right? Even if we have all the right capabilities, design might not surface those easily, and the design itself might not account for all the different user types and situations that the software is used in. But then there's the execution. Even if we have an amazing design, it's perfect, we can sometimes lose track of the implementation. Maybe we cut some corners, we don't execute everything in the design. We might implement something that's not accessible, so we're cutting out, like Ludovico mentioned yesterday, 1/6 or 1/5 of our potential users are affected by something that could be blocked when you have inaccessible software. And then there's performance and security and the error handling stuff that's not necessarily always explicit, but understood in the signals there. So other than that, there's code quality, there's test quality. For me, the only really code quality thing I care about is how easy it is for developers to understand the system itself, what's going on in the code, and how easy can they modify and delete things. And for test quality, there's a code quality aspect to tests as well, the test code being well organized. But really, a good test suite is filled with meaningful tests where you care that they fail, and it's aligned with your goals for quality and your goals for the business. So those are the things I would think of as intangible, but very important to have ownership over related to quality. And then your test pipeline can help you get feedback about some of these things as well. There is no particular solution that's going to be perfect. If you maximized your effort on tangible signals and you measured every little thing, you measured in production, you measured in testing, in your automation pipeline, you'd maybe have an indigestible mess of things to look at and not really be able to form it into actionable decisions. And there's rabbit holes everywhere. And then you also have a very hard time knowing the internal experience of a user. Some people will be generous and share their feedback a lot. They'll tell you what's working, what's not, what their mindset and scenario is when they're using it. And every now and then you'll get exactly opposite answers about whether a feature should even exist or how it's used or what it's for. And so you have to do our best, right? We have to work as well as we can within the practicalities of having one thing that serves more than one set of needs. And then, of course, gathering signals takes work. We have to do some work to instrument things. We have to do some work to pull in the information that would inform our decisions and our ownership. And that work itself has a cost, an opportunity cost against other things we want to do. So it's not free to pick up all the signals. We need to do enough of it to keep ourselves informed. And in many cases, I think people can do more than they are doing right now, but it's definitely not free, and it's not something we can do just as much as possible. So we have a Cypress pipeline, and often when we talk about what Cypress tests do, we think about the pyramid of testing and the relationship between E2E, integration, component tests in the UI, unit tests, API tests. Cypress can technically run all of these different types of testing up and down the pyramid. Even though they don't all need a browser, it's possible, right? So you could use your Cypress test for all these things, but regardless of whether you use it just for E2E or just for component or something like that, filling up the layers of the pyramid is kind of a guide maybe, and looking at different models like the testing trophy and stuff, right? How much test should we put where? It really speaks to the question of why do those tests exist? What kind of confidence are they intended to give us? What are the risks in our specific application that need to be mitigated by predicting the effect of a change by running a test? What sort of things do we really wish we would have known earlier in our development process? And so having answers to these questions and a kind of a strategy around quality and a purpose for the different types of tests lets us put explicit decisions into how we create Cypress tests and what they're supposed to be telling us, how we organize them into projects as well. So I see a lot of smoke test projects and full regression suite projects, and then smaller subsets of tests that run on pull request basis. And those types of organizations are really good for developing signals from the test suite itself. So if you're able to filter down to a kind of apples to apples comparison over time and look at some of those tangible things like flaky rates, like pass rates and things like that, test execution time, those types of information, if you're able to stack up your tests in such a way that you have easy access to the trends on specific suites that have specific purposes, that's great. That gives you a really nice set of information over time that has a consistent foundation and is much easier to analyze. So understanding what we're doing as opposed to a minimum code coverage requirement or something where you must have tests. Do those tests assert things? Do those tests drive the interface that they reach? That type of information is vague if we're just trying to have tests for the sake of having tests. So talking about decisions versus coincidences here, and want to move on to this topic of how many of our products and our interfaces and the things that we do are kind of littered with what was already there. And those are the coincidences I'm talking about, that things just happen to work a certain way, and it's not important enough to change. So a lot of these things build up from time pressure. We are working on projects and there is a need to move quickly. And so you can save time by doing nothing about what's already there. We can save time by saying, we don't have to evaluate this, we don't have to form a decision, and we don't have to execute anything. We'll just leave this one thing the way it is and move on with executing the main work that we're trying to do. Sometimes that means you pare down a feature while it's in progress in a sprint so that you can hit this timeline or something. Sometimes it means you just add technical debt to the code because the way it is now is not friendly to the change you're trying to make. And so instead of making the system easier to change, you leave it as it is and add another little complex independent piece of the system that has some technical debt with it. You also might skip parts of testing that are problematic or difficult, and the different systems that you're testing can be more or less friendly and testable as well. So it can lead to reacting to time pressure by individually cutting some of these types of things. And on an individual basis, those decisions are probably all very sensible. When we would look back at a certain type of sprint or a certain type of effort we've made, you can easily justify tolerating these coincidences. But cumulatively, the effect is greater than it might seem, and it can lead to quality drift and increased complexity and reduced velocity for the team. So it kind of comes into a cycle. I don't want to spend too much time on the cycle, but I think many of us have been on teams where velocity is impacted by debt. And to me, the relationship between debt and just tolerating how things currently are, it can lead to this negative cycle where we have less time to work on bugs. We have more bugs. We have very high urgency about certain things. And one of the things I've seen as a result, as these things reach a point where development gets harder, someone's going to say, we should probably just rebuild it. We should start fresh. We will never make these mistakes again. We'll never have these priorities or this lack of direction again. We're just going to fully rebuild it, or maybe we'll dedicate a sprint or a couple of sprints fully to maintenance. So we'll stop developing new features. And this creates a situation where we might be able to buy some breathing room, but we've also increased the backlog of things that need to be done that were set aside for the rebuild. And often those projects take much longer than predicted anyway, and are more costly than predicted. So it's seldom a really good solution, and incremental improvement is likely preferred. I put the sync meme up here. I really like this one. I think this is a good example of like a massive quality problem for something that is technically a working feature. So if you think of the sink's purpose as to deliver water and put it down a hole and let it go out into a pipe, then you could cut quite a lot of scope from a sink. You could cut quite a lot of polish and execution quality here. And obviously, this would not have the desired intended effect in the world. The quality problem is so terrible that people would not accept this. And where users may not behave the way we expect, or respond to features in the way that we would expect on the product side, sometimes it's because of the overall quality that's harder to articulate as a series of capabilities. It is those things we talked about as intangibles. Is the design right? Are we executing the design correctly? And this tension is a part of like all of the work I was involved in when I was at an agency. We would talk to clients about these types of things, right? I was working on the front end, and the execution quality was really an important part of the relationship with those clients, and took a lot of time. But because they were not the ones really making these decisions, they were accountable for the outcome and the effect in their world. There was a lot of pressure on the execution to reach a high quality standard. So if we see these things and we don't have the ability to act on them, recognize them, and to like put them into our culture as things we want to correct, it's really hard to have ownership. The other theme of this talk being like, how do we take responsibility for the effects of something that is dominated by what was already there and the coincidences that result from tactical decisions over time? The strategic outcome is kind of not looked after if we've done purely tactical thinking for a long time. Because then, is your pipeline doing what it's supposed to? Well, it is a mix of things that are purposeful and intentional and relevant now, and it is a mix of things that are maybe less relevant, and practices that have changed, and things that are coincidentally the way something was implemented by a certain person at a certain time. So the signal to noise, the value can vary depending on which test it is, which area it is, and stuff like that. And all of this was true before we had AI-assisted development. And the AI-assisted development world has some effect on quality and how we manage it and how fast things are changing. So from my perspective, there are a few effects on quality. This is just a little bit of context for how I'm thinking about this. It's not full analysis, but there are a lot of things that are favorable for higher quality in AI generated code, and in AI code reviews, and AI assisted autocomplete and things like that. There are certain things that are easier and faster and trend towards improving quality that AI can help with. And we can also have things like Cypress prompt, where you can have a self-healing locator in a test so that the test maintenance is easier and the test is more connected to describing its purpose than specifying individual aspects that are a little bit of a layer below what the purpose of the element is. So as you saw from Brian yesterday, there's a lot of PsyPrompt thinking around the injection of AI into the process in a way that is intentional and specific to a testing goal. And then there's risk factors for quality. A careless use of AI, a vibe coding type approach where we're not as critical of the output, can lead to a really high volume of changes that have interactions that are complex and haven't been thoroughly analyzed. So we don't simply want to go as fast as possible with AI, because that would omit reviews and sacrifice quality and at least introduce a lot of risk for quality. It also produces a higher volume of changes for reviews and validation and things like that. So if there's already bottlenecks in your process, AI is accelerating parts of it, but unless it accelerates all of it, the bottlenecks still exist, and so the gains are kind of limited in some cases. Quality can drift. If we're repeating a bad cycle that sacrifices quality already, then doing that cycle faster introduces like more quality risk faster. There is a whole new source of coincidences and ownership where ideally everybody who uses an LLM to create code takes full responsibility for every line of that. But potentially if the volume is high, people are not taking full ownership of each step of the code. That's another risk. And then the gains from these tools also produce like time pressure expectations for more delivery as well. So in the optimal use of these tools, you get all the benefits and you minimize the downsides and you keep the awareness of what's happening on quality. But the quality understanding has to exist first. So we talk a lot about shifting quality left, and that's certainly something we can do with Cypress and something we can apply here. But we still need these lines of ownership, these communications and things like that, right? We need meaningful, well thought out tests that have a good signal to noise ratio. They need to fail when they're supposed to fail and pass when things are working correctly. So robustness, reliability in the tests is really important to give us confidence to move faster and give us confidence to merge things that might have been implemented through AI. Well, I think one of the hardest things to review in this whole AI development world is a code change that comes with a lot of test changes and both sides of the equation were AI generated. And in that situation, I would propose understanding the tests first, understanding what the tests are actually validating and if those validations are the correct things, because AI can create a lot of test code quickly. And if the tests are correct, then move on to reviewing the code. Because if the tests are wrong, it doesn't matter what the code is doing. So it's really useful if we do have to look at both sides of the equation at once, that you can do that. Or you can do something that's a little bit more leaning towards like directing the spec first and then letting AI work on building out things that meet the tests. So the approach to this is very similar to technical debt. Like most of what I've described has a lot of overlap with like technical debt as a drag on quality and other things related to technical debt or other forms of debt as a drag on quality. So you can use your test pipeline to help you discover these coincidences and replace them with decisions, like find the owner for something that's not explained. And I would argue almost all the time, if there is something in any part of your application that's just kind of a fluke, a coincidence, you look at the UI and you put these two components next to each other and they look weird, but they're both correct from your design system, that's a good example of like, we have a coincidence, but the effect is lower quality. If anybody at your company who knows about your quality goals and like cares about the outcome there would make a decision about a UI tweak to accommodate that coincidence, that effect, it's almost always going to be an improvement. It's going to be at least somebody thought this was better, and you can implement something that represents your intentional quality strategy. And gradually over time, those small decisions all accumulate to start to point in the same direction and improve quality itself. So here's how I kind of represent this. Like we have a pretty good innate sense of whether a room would be considered tidy or not. In a situation where quality is low, it can feel like there's many different contributing parts of the thing that are wrong and off. And that's where we get like, oh, we need to rebuild, and do these big projects. But it's entirely possible that we can incrementally take on pieces of this work and develop the overall sense of quality and genuinely improve things to where quality is actually better in a large way, even though we've done tiny increments of tidying up one thing at a time opportunistically. So shifting left is actually really good for this. when we talk about shifting left and getting feedback like before merging versus after merging, um, one of the reasons that's cheaper and faster is the person doing the work, like changing the code base, has a kind of open loop in their mind. They have staged a bunch of changes that are ready for review. They haven't yet committed them. And so all of that context about how the code works and how the pieces fit together, that's all right there close to hand, because when you're the developer, you might need to use that in case someone finds a line of code or a bug or something comes out of the feedback in the PR. So testing before merge is a fantastic opportunity to get some action taken with a really low overhead. And if you can spot a new quality issue in your tests or your code while the pre-or is open, you can quite often get away without making a ticket and just point it out and it'll get addressed, and there's very little impact. And then 5 minutes after you merge it, you take that same exact issue and you raise it in the backlog and you put it in planning, and it takes on this overhead of like decision and regaining context that you might need to do, and it just becomes like a bit of a heavier process. So not to say we should cram everything into PRs that we want to do and like not ever make tickets for quality work, but we can leverage the existing process really well. So now I'll talk a little bit about UI coverage and accessibility. These are the things that I am the product manager for, and they are intended to help leverage the existing process you have. So I figured here I would introduce those and not really get into too much detail in the weeds, but just describe like how they can help you get visibility into these. And there's plenty of demos, there's documentation, there's stuff on our website. You can explore these to see if they're a good fit for you. But the premise of these, I think, is worth knowing about if you're using Cypress Cloud, or if you just got a Cypress Cloud account to try like sci.prompt or something new like that, and you want to see some feedback from this angle on those tests you're generating, that can be really useful too. The main thing about both of these is we develop the information from what you record into Cypress Cloud when you do a test run. So if Cypress Cloud is involved and managing your parallel runs or doing spec prioritization and things like that, you are already recording tests that upload test replay information. And so UI coverage and Cypress Accessibility can transform that set of data into insights based on the tests, purely based on test replay recordings themselves. So there is no setup, there is no activation energy to start to use your existing tests to drive these types of insights. You can just do it. So UI coverage, just telling you what it is. It's a test coverage type solution. You can see a heat map here, and this is kind of the characteristic interaction where you will go and look at your application and find elements that don't have tests. And it works with one moment in time, and it works with comparisons. So you can see a lot of details about elements that have, interactions in one test run and don't have them in another, and dig into the explanations for those things. So these slides are here as a summary, and they'll be available as well. So I'm not going to kind of go into every bullet, but this is useful. And there's an AI test generation aspect. So if you do identify something that you think needs a test, you can spin up a test from that like moment in time in your application. Let's say it's something deep in a modal. You can grab that moment and start a test, and then take it down locally and open up Cypress and extend that test, like with Studio, or add some prompts to it to finish it off. But there's this nice handoff between the cloud report and actually doing some action to improve test coverage. And that lowering the effort to get started while you have a PR open and it's easier and faster to implement things, that makes a huge difference. So we'll look at this example here. This is just how something like UI coverage works. And I highlight this because it's different to some things people might expect. Often encountered people who see the name UI coverage and think visual testing. This is not a visual like, screenshot diffing tool or something like that. And it's not code coverage either, which is the other kind of reference point. So this type of heat map based approach is a distinct new metric to track. And it's based on something like the interactive elements in your page. I'll say before we go further, you can influence everything about this. You can influence what's considered interactive, and you can influence what gets in and out of the report. But basically, if you have some Cypress tests that are doing different things on a page, whether it's one test or many tests, we can analyze the information from those tests to tell you what was used and what was not in your application and produce something like a score. And like I said, this is the core thing. If you have this information on one run, that's like interesting. It's like an audit. Okay, we can see everything there. And that does sometimes reveal coincidences. But more often than not, it's the change. It's the branch review experience in Cypress where you look at the diff in coverage that explains some change in your score. And that's where you're digging in and getting the opportunity to make a decision about what has changed. So if score went down, if you like lost coverage on your login page, it might be because you added functionality there that didn't have a test. And that's very valuable information to know because anything on your login page is probably high priority to be working and makes sense to have a test for it. So there's a bunch of coincidences, as we've described in here, that you can surface in something like UI coverage. You can see different pages have different patterns of testing. You can see repeated testing on elements that have low value. If you refactor tests, you can see if coverage changed on the actual interface, which is really useful because sometimes the coincidence of like, how do we find ourselves looking at a bug? It's like, oh, I deleted a test that was called like, purchase some sneakers, but it was the only thing that happened to check the contact form or the discount code or something that was not tested elsewhere. And so knowing that there's an impact of refactoring around these interactions and when you're losing coverage is very helpful for turning those things into decisions you can then own and rationalize about and have some understanding of. Under Cypress Accessibility, so you got a tiny preview of this yesterday as well in the accessibility talk that was done. And I won't really repeat too much of that, but if you're needing accessibility as a topic or it's important to you, then having just like a passive system that drives accessibility checks from your existing tests is very useful. Nobody has to know how to use it. Nobody has to know how to correctly add checks to the system or anything like that. You can get all of the like hookups into test replay to reproduce debugging and things like that. So a bunch of stuff comes with Cypress Accessibility that would be onerous to build on your own and support some workflows that can be pretty advanced depending on the needs of the team. And here you can see similar profile of coincidences, like knowing, especially one of the pain points of accessibility is you fixed one thing and you broke something else. So knowing, here's a pull request that like fixes my nested interactive failure, right? Buttons inside of other buttons or something like that. And so you repair that issue and then you push up the component and you see the effects throughout your end-to-end tests of fixing that problem. And you discover you have introduced a naming problem and you have still got a screen reader issue with accessibility for usability of your application, but it's now something different because your DOM update had an unexpected side effect. So just surfacing these things, being able to contextualize them, again, while a PR is open, you have more opportunity to drive the interactions there. So I'll kind of wrap up here. We'll be able to move on to the Q&A. I want to talk about like how to act on some of this stuff. And like I said, I have lots of conversations with customers who have various experiences with Cypress, with testing, and various formats of teams. Some teams are all developers. There's no QA explicit teams or culture around how we do QA. Some teams using Cypress are purely the QA side of the house, and it often seems like they don't really know the developers. The relationship with development can be maybe a little contentious sometimes, and so there's all sorts of different patterns. So hopefully this applies to at least some of you around how we can start to improve quality through a fairly simple rubric of like, hey, is this thing a decision or is it a coincidence? And just generally over time, trying to improve the ratio of stuff you decided, someone who knows your quality strategy decided, versus things that just are the way they are. So like I said, in the example of tidying a room, the small changes accumulate. And we looked very much at the pre-merge process, but there's a lot of decision-friendly points for fixing some of these things. One of the main ones is actually the requirements themselves. When we're developing the product requirements and the expectations for something, figuring out, are we inheriting existing patterns uncritically, or are we doing the right thing for the current situation? Definitely during active code changes. When working on brand new tests as well, we have an opportunity just to leverage the active mindset as we merge those tests to look for the value of related tests and figure out where new work fits in. And then looking at a failure often is a chance to, stabilize the system around that failure, not just put a Band-Aid on the immediate thing. It's very true for accessibility as well. If you have small, easily detectable, important accessibility issues in a certain area, it's kind of a pointer that this is a hotspot, and it's a good place to focus your efforts on making sure the surrounding component was built in an accessible way. Developing habits of like having conversations to question, hey, is this thing intentional? I think is really useful. And for a lot of these things, you can guarantee an outcome from routine small changes over time. You can guarantee that outcome over a year, you will have some effect. Versus a large plan to change the world that just sits on the shelf, you have no guarantee of any output from that until something else changes to support implementing a large effort. So the progress, incremental though it may be, on every level, on every part of the team within who works on the product, but also support and sales and everybody else, that does improve the quality of the interactions there. And if you're interested in what I showed a little bit with UI coverage and accessibility, we have free trials. Everything's on our website. You'll be able to go into more detail and assess if these are good fits for what you're doing. But overall, yeah, hopefully this has been kind of a helpful tour of at least of these topics as they've been coming up.
Thank you so much, Mark. That was a really incredible look at how visibility and ownership shift the entire quality conversation. I think all of us are going to be walking away making sure that our test suites do more than just technically work. We have got a lot of great questions coming in from the audience, so I'm going to start with sharing some. So let's go with this one first. How can the concept of shift left be introduced to management in an agency setting where the requirement gathering and the design phases are handled externally by the sales team and development only begins really after the contract is signed?
So actually, the agency setting is really interesting to me. I worked in an agency, as I mentioned, and we had kind of both models. We had some like marketing departments who didn't have a strong opinion about the requirements as such, and we could work as developers like directly with those customers in the meeting, defining the work and setting expectations there. When it comes to places where things are defined up front, I feel like it's necessary for the sales team, in that case, like the other team, to set some expectations around like what are the quality guarantees. And some of the customers of agencies don't really think about testing, but tests should be part of like what they're paying for. And my experience with customers who were like, hey, what are the automated tests for this? Those are supposed to be there. Was pretty good because they would do manual validation on everything before releases and things like that. But they also had an expectation that the agency was taking care of quality. And internally, if you have a long-term relationship with the client, you benefit from the automated tests yourself because it's cheaper and easier to make changes. So the rationale can kind of be rolled up into the long-term relationship of effectively working for them, that you make your life easier by having automated tests. So unfortunately, I guess it depends on the customer.
Yeah, that's great insight. And I think I have another question from the audience to share for you on stage. And this one takes a bit of a different angle, right? Not necessarily about the content that you've presented, but as your role as product manager at Cypress, how much does the Cypress community impact the decisions that you all are making day in and day out?
Answering for myself, I look at everything I can as like a signal on what's useful. I think we look at things like the GitHub issues as driving what requests there are for the app and things like that. So this year, for example, the tab key implementation was our most upvoted issue at that time, like in a request. And that was a part of deciding that it needed to be implemented and the availability was there to do it. So I think that the yeah, the community signals are incredibly important at Cypress. So it's hard to give a qualitative answer to like how much the feedback influences things, but it's certainly hugely valuable and welcomed and like important to our internal processes for sure.
Excellent. Thank you, Mark. I'm going to share another question, and this kind of goes back to the content specifically you were presenting here. Do you agree that nowadays it is increasingly important to not only test features and report defects, but also participate in product development and other processes as a whole? So getting quality feedback really early in the stage of bringing a feature to market, not just after the technical team has technically been engaged.
I think that that's a very good pattern. There's a testing mindset that like some people who are full-time testers have around speculating on edge cases and also understanding how systems interact. That's very valuable early in the process. I have been at places where the QA people have the absolute best understanding of anybody else in the company of how the product works as a whole, because they're constantly exercising it. They know all the shortcuts and the routines, and they know the interface, the core functionality really well because they're involved in all of it all the time. So drawing connections between pieces and spotting things that could be bad interactions, it's great if quality is involved early. I've also seen patterns where like quality specialists are embedded in the sprint and in the development team doing like help with unit tests and specs and things like that. So like actually involved in the development cycle on a routine basis as well. And I think that's great.
Awesome. And then we have time for one more question from the audience. So I'm going to go ahead and share that. You talked about tangible and intangible quality signals. Any tips on how to present overall quality metrics to leadership when the latter, is kind of hard to quantify?
Yeah, this is a great question. So the relationship between the two like needs to be articulated. We can't just present like the performance numbers. The dashboard you might make for leadership is like what they're usually wanting is, are we in tolerance or not? Are we having an acceptable performance of our API requests or something like that? There are some experiments you can run related to quality as well. So if you look at some particular aspect of the design or whatever, and you want to see the effect of changing something and look for a tangible measurement of that, that's kind of inferable to say, oh yeah, well, we improved the what's the word, like the availability, we improved the ability to recognize, discover this feature. So we expect more people to use it and give us feedback about it. And those types of mini experiments are good if you need like more hard data on design improvements having an impact. And then finally, like even if we look at something like UI coverage and Cypress accessibility, part of what they're intended to do is have the like relatability of, hey, it's your visual test replay style representation of your app. So we go from coverage is like 80% to, hey, here's things that are in red. And if they're not working, our pipeline is still passing. And is leadership comfortable with like these recognizable parts of the application? So some of it is like not easy to do without some new metrics, but a lot of it is how can you make a judgment call about something tangible that you can plausibly tie to quality that's harder to measure. And then, of course, like user surveys and feedback and things like that, more qualitative, easier to relate to the actual metrics you're tracking over time.